In 2015, we had a meeting with Sam Altman and Ilyas Escobar, and the things they were saying sounded crazy. Oh, we don't have to worry about safety. Company that's achieved Moore's Law in the last few years.
They raised $1.1 billion. They have now an $8.1 billion post-money valuation.
The sale of advanced AI chips to the Middle East, striking a deal to export up to 70,000 to the UAE and Saudi Arabia.
Here's one. I'm with Cerebras, and this is their new chip, the wafer-scale Engine 3. AI agents are going to take over, and you're looking at them saying, this is crazy talk. And what Ilya said was true. When a new workload occurs, a new computer architecture emerges, and new great companies are born.
Trying to create a chip company in 2015 with existing players, it's not an obvious thing. What was the thesis there back then?
Let's see how it goes. All right, we're done. You're going to have to clap for like 30 seconds because I'm going to make you suffer through this whole thing here. We chose to build the largest chip in the history of the computer industry. This is 56 times larger than the largest chip that had ever been built before. Tesla tried to build a competitive chip to us, and it was called Dojo, and they recently shut it down. They failed. Microsoft has tried several times. Facebook has tried many times. Their internal projects have not succeeded to date. You know, to be 30 or 40% cheaper is not a good strategy. I think you want to be 10 or 15 or 20 times faster, and that's what we are.
What do you think about this idea of like compute in a commodity?
It's an irony because NVIDIA's gross margins are 73%. I mean, of course it's not a commodity. I mean, look.
Today's number is $400 billion. That's how much money just the four hyperscalers, Microsoft, Amazon, Meta, and Alphabet are spending or expected to spend in this year alone. For context, that's more than 15 times the Manhattan Project, 2 times the amount of money it took for us to do Apollo program, which literally put the man on the moon. And that number could globally reach $3 trillion. We are arguably in one of the most biggest capital spending cycles we've ever seen. And it's all centered around this one big question. How can we get more and faster compute at scale? My guest today fits rightly at the core of this question, Andrew Feldman. Andrew is a brilliant co-founder and CEO of Cerebras Systems. He's a serial entrepreneur with a remarkable track record. Previously founded C Micro, a company that changed server architecture and was later successfully acquired by AMD. Now at Cerebras Systems, Andrew and team is once again pushing the limits of what's possible in one of the most formidable challenges in modern computing, the insatiable demand for AI compute and inference. Cerebras is building a new kind of AI chip from first principles. They're engineering an entire wafer-scale systems, like the groundbreaking WSC3, the largest AI chip ever built and designed to deliver unprecedented AI compute power, efficiency, and most importantly, inference. They're at the forefront of AI hardware innovation, challenging established giants like NVIDIA, AMD, and redefining performance benchmarks with their unique architecture. The latest accelerator, WSC3, boasts an incredible 125 petaflops of AI compute with 4 trillion transistors and a significant leap in inference speed, a massive 21x times their competition. For founders, operators, and investors navigating the world of AI, this conversation will offer invaluable lessons in innovation, market disruption, building a chip company, and scaling a deep tech company. So get ready to deep dive. Andrew, welcome to Startup Project.
Thank you so much for having me.
So while I started to research Cerebras, I know of Cerebras because, I obviously follow all things AI, but I didn't know where to start. So I thought the best way to start is, go to the first-hand resource of you talking about it in your event, the Supernova 2025. And the one thing that really stuck to me was the demo that you did with ChatGPT, Claude, and Mistral Chat, which is on your own infrastructure. And that sort of crystallized this idea of, okay, what kind of experience a user can have if you really improve the inference speed. And that sort of like really crystallized the idea. I want to talk about that, but before getting into that, in 2025, it's obvious that, to work on an AI chip or to work on inference or to do this, a cloud computing company, there are a lot of neo clouds coming up right now. But you started the company in 2015 and trying to create a chip company in 2015 with existing players, NVIDIA, Intel, AMD. What was the thesis? I mean, it's not an obvious thing like to start a chip company? What was the thesis there back then?
I think there are two parts. One, as a chip and system guy, that's all we know, right? So it's obvious to us. I mean, we weren't gonna build a web app. That's not who we are. And I think entrepreneurship, like many things in life, pays dividends if you stay true to who you are. We are the founding team, and the people we know are infrastructure builders, and that's what we love. And that's what we've done our whole careers. And for me and the founding team, it's building chips and systems and the software that runs them, such that other people's ideas can run on our machines and their ideas can take flight. And that's what we love doing. And so, this is my fifth startup, and all the previous startups were building systems. All the founders, all my co-founders were with me at the last startup I founded. And so it was obvious to us that we were going to build a chip and a system. I think what wasn't obvious was AI. And, in 2015, NVIDIA was a $20 billion company, not a $5 trillion company. Right. The world looked very different. I mean, we had a meeting with Sam Altman and Ilya Sutskever, and the things they were saying sounded crazy. Oh, we're gonna have to worry about safety, and AI agents are gonna take over, and you're looking at them saying this is crazy talk. And what Ilya said was true. It happened. What we saw was a new type of compute, and that we thought AI would usher in a new compute workload, in the same way that cell phones ushered in a new compute workload, in the same way that switches and routers in the late 90s ushered in a new workload. And when a new workload occurs, a new computer architecture emerges, and new great companies are born. When there's an existing dominant design, as there's been, for example, in x86, there's been some change in market share between Intel and AMD, but there have been no meaningful entrants in 2.5, 3 decades, right? Whereas at this inflection point, at this sort of with the rise of a new workload, there is tremendous opportunity. So when the cell phone workload emerged, who was better positioned to take advantage of that than AMD and Intel, right? Both failed completely. Zero share. Right. And new ARM emerged, and Apple emerged as a major player, and Samsung, and they'd never been in the compute business before, in the chip making business. And so when you see a dislocation, and that's what we predicted. Now, we clearly didn't think it would be this big, or we would have raised it a higher valuation. Right. We had no idea that 10 years later, people would be spending $400 billion on CapEx. So we had no idea. I mean, in 2016, AI was finding a cat in a picture and making sure it was not a chair. Right. That's where AI was. But we saw a trajectory that would be big. We didn't see that it would be this big, but we saw a trajectory that would be big. And we came to believe that we could build a new type of computer. A type of computer beginning with the chip and the processor and the system that would be really good at this workload, that would be not a little bit better, not a little bit cheaper, but orders of magnitude faster. And that's what we did.
What does an iteration cycle look like when you're trying to achieve that? Because if you're building a software product, it's pretty straightforward in terms of how the cycle looks. You start with an MVP, you revise it, you improve it, take feedback. But how do you, do that for a hardware product?
What we chose to build the largest chip in the history of the computer industry. Right. This is one chip. And
Context, typical chip is like this size.
the size of a postage stamp, the size of your thumbnail. Right. This is 56 times larger than the largest chip that had ever been built before. And so we set out to do fundamental design, creativity, engineering innovation and invention. And we spent about 3 years, and when all was said and done, about $500 million to make the first one. And nobody in history had made one this size. And by being bigger, we could keep more data on chip. We could move it less often and less far. We could use less power because moving data is really expensive in power, and it's expensive in time. And so we could be much, much faster. So the dividend of doing this was huge, but it took us years and a great deal of sort of internal fortitude, because it wasn't right the first time or the second time or the eighth time. In fact, we had about a 15-month period where we were spending $8 million a month and we couldn't make one. Right. And so you're going to a board meeting every 6 or 8 weeks saying, nope, still can't make it. Still can't make it. And then in sort of July or August of 2019, we made one. And the founders we stood and in a tiny little lab, and we watched a computer run, which is about as exciting as watching paint dry, right? I mean, it's just a big metal box with some lights flashing. And we looked at each other and we were stunned. I mean, we'd solved a problem that nobody in the computer industry had ever solved before. And we, a few months later, we had our first customer. We have been on a tear since then.
Who was your first customer?
Our first customer at the government was Argonne National Labs, one of the Department of Energy labs in the U.S., and our first commercial customer was GlaxoSmithKline, the large pharmaceutical.
So what is the advantage of you build the largest AI chip, and it can have 4 trillion transistors, but what does it mean when you compare it with, the thumbnail chip? Like, can you pack more SRAM on top of it?
That's exactly right.
How much bandwidth do you get?
That's exactly right. So memory has 2 types, right? There's slow memory that can hold a lot, that has high capacity, and that's called DRAM. And HBM is a flavor of DRAM, and that's what GPUs use. And they're called graphics processing units for a reason, because they were designed originally for graphics. And graphics was a problem where you'd move data once, you'd do a lot of work on it, a lot of work on it, a lot of work on it, and then you'd bring the results back into memory and you'd move a new block. There's a different type of memory called SRAM. And historically, SRAM was extremely fast, but was relatively low capacity. It couldn't store that much. And so by going to a big chip, we could stuff it to the gills with SRAM, overcome the limitation of SRAM that it couldn't store very much by using a lot of it, using all the real estate on the big chip so that we could build an SRAM solution. And the result is we have both capacity and speed. And, that's why we're 15, 20, 25, 30 times faster, and in some problems, thousands of times faster than B200 GPUs.
So if you have more memory, then if you're doing, let's say, pre-training, you don't have to break down more often than you would have to do it on a GPU and combine the pixels. Is that the advantage that we're getting here?
That's right. Let's look at inference, because it's a neater example. In generative inference, to generate a single word or a token, you have to move all the weights from memory to compute to do a giant matrix multiply, right? A 70 billion parameter model, which is not a very big model, you're going to move about 100 full-length movies worth of data to generate one word. Now, if your memory is off chip, then you've got a thin little pipe to the GPU. You've got this memory that can store a lot, but is slow, with a thin pipe that goes all over here to your GPU, and you've got to move 100 movies worth of data across that little tiny pipe to generate one word.
And that would be across a cluster of GPUs.
That's across a single GPU to get to its HBM. It's even worse if you have to go across a cluster of GPUs. That pipe is what we measure it in bandwidth, in memory bandwidth. And by putting the SRAM right next to the compute core on the same silicon, right, we move more than 2,600 times more data more quickly. And as a result, the inference results come out faster. And it's just that simple. So memory bandwidth is a known Achilles heel of graphics processing unit architectures. And it was one of the things we saw in our design that we could do vastly better.
Do you see that, right now it's all about compute and pre-training or maybe I would say like that sort of like ended last year and everyone is still like saying, we're scaling inference. 2-3 years down the line, do you think we'll spend as an ecosystem more on inference than compute?
Inference and training are different, and until about the beginning of 24, maybe the middle of 24, AI was mostly a novelty, right? It was sort of cool, but it wasn't doing real work, right? And during that time, everybody focused on training because training is how we make AI, but inference is how we use AI. And when AI in general was a novelty, nobody was using it. And what's happened since sort of the summer of 24 is the use of AI has exploded. And that's what people talk about as inference explosion. And, not only have more people been using it, but they use it more often and they use it to do more complicated things. Each of those increases the compute. And so the compute needed is a product of 3 rapidly growing dimensions. That's exponential growth. And so that's what's happening. And that's why inference has just exploded.
What is it like for a new chip company to compete in this space with AMD and NVIDIA?
It's hard. I mean, I think, look, Jensen and Lisa Su, Lisa bought my last company, and I think they are 2 of the 3 great CEOs over the last 10 or 15 years. If you throw in Hock Tan at Broadcom, those 3 leaders have outperformed just about everybody else in the world, let alone
Probably in the history of finance.
That's right. Right. Maybe in the history of public markets has done as well as anybody. And they're dazzling. But their size also creates opportunity for us. They can't move as quickly as we can. They can't take the type of engineering risks we take. They can't hire the caliber of people we can hire who don't want hierarchy and structure. And so there's tremendous opportunity for the bold entrepreneur. And, you both have to take the giant in the field seriously, and you have to know that they can be beaten.
In some ways, I mean, you've done now 5 or more companies. Is it better to, as a strategy? I know like what you said really resonated is the fact that, you stick to your lane, what interests you, what curious you, what your strengths are, focus on that. That's always there. But if I backtrack it as a strategy, it's always, I think, a little bit better to take a very big problem, very high stakes, very hard problem than, something which sounds a little bit more easy. Is that a fair statement to say?
I think, Nataraj, it depends on your passion and it depends on where you are in your career. I think I think chip projects are enormously expensive. And historically, they've not been a good place for young first-time CEOs. there are a lot of returns to experience in the chip business. Now, there are other parts of the entrepreneurial ecosystem that have been extraordinarily good to young CEOs, particularly where they and their friends look like their customers, right? There they have unique expertise that experience can't replicate, right? When they're coding for their friends, when they're building tools that they want to use, right? That entrepreneur has experience and has advantage. And obviously, the entire wave of social networking companies were like that. I think there are many AI companies that are like that, where right now, some of the most knowledgeable and creative people are just finishing their postdoc, right? It's not those of us with 20, 25, 30 years of experience that have the most to say there. But in the chip business, where not only do you have to design the logic in a chip, but you have to have relationships with a fab. You have to use EDA tools that cost millions of dollars a year. You have to do back-end design and physical design. You have to close timing. There are very few great hardware teams, maybe 8 or 10 in the world, and we have one of them. And they've been with me for 20 plus years.
Yeah.
I think I think that made it easier for us to raise money for a big idea.
I think what do you think about this idea of like compute, becoming a commodity, or inference then becomes a commodity? Like this whole commodity narrative that sort of flows around.
It's an irony because NVIDIA's gross margins are 73%. I mean, everybody's saying it's a commodity, and they've got gross margins in the highest of any hardware company in history. They've got
That's
gross
also
margins
true
that
of a
make
lot of like
software
even
companies.
storage products.
Storage is still a great business, right?
Yeah,
I mean, look,
people say it's a commodity.
storage is a commodity, and yet you've got Vast and Weka and all these guys, and Dell continues to make huge money on their storage. And I mean, they bought Extreme IO, one of the great acquisitions. And it's a commodity, except if you need it in the enterprise, except if you need dedupe backup, except if you need, right, you're going to put banking information there, then you need security. And I think as you know less about something, the details and the complexity go away, right? As you zoom back, I mean, look, from the moon, the Earth is just a blue and white orb, right? And you get up close, and it's like, oh, there are religious battles and political battles, and there's technology battles, and there's, right? And so I think people who don't really know a domain often throw stones at it. Oh, that will be commoditized. And you look at AI compute is not looking like it's going to be commoditized. I mean, Andrew Ng said the other day, and Andrew Ng is a professor at Stanford and truly one of the more thoughtful minds in our space. He's not given to wild statements. He said he's never met anybody in AI who feels they have enough compute. Right? I mean, that's not a market driving a commodity.
Yeah. And it's also like what you point out about enterprise scale is at that scale, it's not commodity. And if it's a commodity, then why does Meta pay $100 million to a research engineer?
That's right. Of course, it's not a commodity. I mean, look, the reason you pay Kylian Mbappe big money is because he has skills other people don't. Right? That's it. The reason you pay Shohei Ohtani is because he has skills other people don't. It's not because of anything other than the fact that their skills are in demand and their skills are unique. And I certainly think there are a collection of AI engineers. They're actually a collection of people in each industry who have skills that are so much ahead of the others that they're sort of rare and impossible to replicate. Right? No number of really good engineers equals an extraordinary engineer.
Yeah.
Not an additive thing.
Yeah.
And so if they have these, the key, Nataraj, isn't have we overpaid a great guy? Nobody goes bankrupt by overpaying great engineers. You go bankrupt by overpaying mediocre engineers or pretty good engineers.
Yeah.
But great engineers are extraordinarily rare, and I don't begrudge them one nickel.
Can you talk a little bit about like your product strategy? Because you have this chip, now you have to get that chip into the hands of customers. You have, you obviously have data centers that you're building, which obviously have Cerebras infrastructure. So if I just break down the product types, you have the physical chip, and then you have data centers that I'm not sure if you own the data centers or you're partnering with others. And then you have your own cloud offering so that people can access, your infrastructure. And then I think there's a fourth one, which basically is mostly of a business offering, I would say, is you also enable putting Cerebras infrastructure in customer on-premise environments as well.
That's right.
Is that like all the different things, or is there anything I'm missing?
That was really pretty close. I mean, we don't sell the chip. We sell a computer, the chip in a system, and sort of that's parallel to, say, the NVL72, right? We sell a whole solution, comes in a rack, it's delivered, it's got everything you need. We will deploy that on your premise, or you can buy cycles on it from our cloud or from our customer's cloud. So you can buy it through Amazon Marketplace or Microsoft Marketplace. You can buy it from Open Router or Hugging Face or Vercel, or lots of other places where you can jump on exactly the way you prefer. You can buy it from us, you can buy it from our partners. So we have both offerings, if you want a cloud offering or if you want an on-premise offering. And you can bolt on to us via an API. So the same sort of industry standard OpenAI-like API, you just bolt on and you go. The final thing we do offer is we will offer to large on-premise customers some forward deployed engineering, where our engineers collaborate and work together with your engineers, and maybe we're designing models or cleaning data or working on a data pipeline in order to accelerate the delivery of the solution. So systems on premise, cycles in the cloud, our cloud, our partner's cloud, and then we're happy to collaborate with you, bring engineering services to bear to help you get to market faster.
So you see a lot of companies, out there. I can think of CoreWeave, Crusoe, and other neo clouds that are building clouds.
N-scale, Nebulous, the
Nebulous.
list goes on and on.
Yeah. So,
Fluid Stack, I mean, the list goes on and on.
but none of those companies have their own chips, which is, I think, a unique differentiator that you have.
Right. All of those are dependent on NVIDIA.
Yeah, and I
All
think
of those are basically NVIDIA resellers.
got it. And how do you see that model? Because then you're almost becoming like a sort of a partner, because we always have data center partners who run data centers for other companies, right?
Yeah.
How do you see these neo cloud businesses that are sort of anchored? Some are anchored on OpenAI, some are anchored on NVIDIA, and then I see in public market, there's DigitalOcean, for example, right? It's valued at $2 to $3 billion, while all the neo clouds are valued at, I don't know, 10 to 20 and more. So there's a big dislocation there that I see. I don't know if DigitalOcean is undervalued or these are overvalued. And in terms of as a business, it doesn't seem like it's going to be a high margin business for that neo cloud itself.
It's a low margin business. The question is whether it's a high return on equity in business, because they use a lot of debt. There's no doubt it's a low margin business in terms of gross margin, but the return on equity, because there's so much debt being used, may well be high. So it may well end up looking more like a real estate investment, right? If the return on real estate is 5% per year, but you've only put 20% of the value down, right? The return on equity, all right, is much higher. And so debt confuses and makes more complicated the analysis, for sure. I think, I'm certainly not running out and shorting Equinix or Digital Realty Trust or any of the traditional players. I think they run enormous businesses. They have long contracts. They have power contracts, and they're global. And those are exceptional companies. I think the upcomers are startups in their own right, and they're trying to find a niche, just like we're trying to find a niche. They're trying to offer something that was difficult for the incumbents to offer. They're trying to move more quickly than the incumbents. They're trying to offer power behind the meter, which means right next to generation rather than on the communal grid. And some of them have chosen, like Crusoe, to build. Right. And so they are now construction firms. And that's very interesting. And so I think, I don't begrudge them their dependence or reliance on NVIDIA right now. I think you probably don't, as a business proposition, want to be dependent on one supplier. I think that's probably not good for your ability to flourish. But I think to get started, I think they're together as a group. They've done amazing things.
I'm curious about your decision of not selling the chips because, I mean, NVIDIA has this premium, price where, they still have 80-90% margins. Why not, as a business strategy, sell the chips that you have?
Well, I think I'm a believer in the system business. I think it's very hard to get paid for software when you're selling chips. And historically, there are very few examples of a successful entry strategy when you sell the chip on a PCI card. I mean, the way you sell chips is on a PCI card, right? And then you're dependent on Dell or Supermicro for your I/O and your power, right? And that you're dependent.
So if I'm a customer, I want to do inference, then I have to talk to all these vendors, create my own, build a whole rack, build a whole infrastructure.
That's right. You got to buy Dell servers. You got to buy pluggable thing. I mean, nobody's doing it that way.
Yeah.
I mean, everybody's buying at these large volumes. Everybody's buying either DGXs or NVL72s or Cerebras boxes. In fact, think about it this way, Nataraj. AMD was so far behind in building systems that they had to buy ZT, and they paid $6 billion for a commodity system maker because they didn't have the expertise. And in this market, building systems and delivering systems is the way consumers wish to consume, and even the way cloud providers wish to consume.
You also talked about you are available on all the marketplaces, right? Talk to me about a little bit about the marketplace strategy. When customers are going to the marketplace, are they hitting the Azure data center, or are they hitting your data center deployed? I know I think you have a data center in Oklahoma.
It depends on which customer. When you use Compass from G42, which is sort of very popular in the Middle East, you're generally hitting their equipment. When you go to Microsoft Marketplace or AWS Marketplace, you are hitting our equipment in our data centers that their tokens have been directed to us. So we've made it easy for you to purchase, but you're hitting...
It's more like a software marketplace rather than a hardware, first-party hardware solution. Makes sense.
Exactly right.
The one of the other challenges I feel is pretty often discussed as well, rightly, is the whole CUDA challenge, right? One of the reasons why workloads, I mean, if I'm starting a new company or new chip company, that's the daunting task is how do I make this transition from CUDA to whatever I am building to access my chip, right? I think that's one of the biggest reasons why Apple still dominates US consumer market and phones is because even though they'll launch a feature that has been out there on Pixel, Google phone for 5 years back, right? It's my constant complaint about Apple is They're
Everybody's complaining.
launching what Pixel launched 5 years back.
It's everybody's complaint. All right. I mean, the truth is uh, what Apple is good at is not features, right? It's the features in a Samsung phone are extraordinary. Apple's understood easy use and cool, like nobody on earth. But that's a good segue because when you do inference, you don't use CUDA. And so the rise of inference weakens CUDA. And I think that's a really important observation, that developers that want to bring a cool chat application into their app, they don't need to know any CUDA. They just need an API to bolt onto a chatbot. If you want to do deep research, you don't need to know any CUDA. You just bolt on to a reasoning model. And so while CUDA is a moat in the training business, and we've developed techniques around that, we've developed compilers that take in PyTorch. In the inference business, CUDA is irrelevant.
If like someone is already running inference on like a NVIDIA GPU cluster, how easy or difficult it is to just switch over? Sorry?
10 keystrokes.
That's amazing.
If you're using, say you're using OpenAI on Azure, your API says something like get underscore OpenAI underscore something. You just change it from OpenAI to Cerebras. You pick your model. You say, I don't know, Qwen 235B or OSS 120B. That's it. It's literally 10 keystrokes.
Yeah, because I think that's one of the factors which defines, especially, I think Satya was talking about this model of fungibility, and
That's right.
to use anything everywhere. And I think that's a really good feature when customers are trying to, because that even if I think of myself and I'm doing applications or developing anything, these are smaller things that make me not shift to a new application.
Nataraj, I think you're exactly right. The reason people get screwed up or miss ease of use is because it's not one thing. It's hundreds of little annoying things, right? And that's why inference is so threatening to CUDA. It is because it offers no value. It is not even in the loop. You just direct the user's tokens to your API.
You have one of the biggest strategic partnership with G42, and I don't think a lot is talked about like what G42 is. Can you explain like what G42 actually is? Is it like a institution, a nonprofit? Is it a sovereign institution? What is G42, and how should I think about it?
You should think about it as a sovereign institution and a national champion for the UAE. They're the AI national champion in the United Arab Emirates. And the leadership in that nation has decided to make AI a priority. And they are building data centers. They are investing in AI technologies around the world. And they're building large partnerships. And we've been working together for several years now. And it's been extraordinary. We have built out for them some of the largest AI data centers in the world, located in the US. We recently received licenses to deliver equipment in the UAE. So we'll be doing that over the course of the next 6 or 8 months. But this is a huge partnership. Together, we've trained models in Arabic. We've done genomic research together. We serve customers throughout the world together. It's a very powerful thing.
Well, one of your engineers, I think it was at an ML conference or something, was talking about like you discovering inference being faster because you were trying to solve the training problem. on your GPUs. Can you talk a little bit about that, like how that happened?
I think between about 2000 and 2024, there wasn't an inference business out there, right? Nobody was doing inference in production, right? Until ChatGPT, nobody was doing large scale inference at all. And so all of us were doing training. And what we saw was that the architecture had such enormous advantages, not just for training, but for inference. And, I was probably, too slow in recognizing that and shifting or adding resources to build out our inference program. I wish I had done that 6 or 8 months earlier. But right now, that business is on an absolute tear. And so, yeah, I think there is no substitute for working with customers and building things for learning and for product strategy, right? It's very hard to do it in a conference room.
I think there are a few original chip makers out there. I feel like if we have to like think about competition, I think, TPUs from Google is one, Grok is one, Tesla has its own chips, but I'm not sure how big of an impact they have or might have. How
I
do
think
you see like architectures of these different
sure.
things?
Tesla tried to build a competitive chip to us, and it was called Dojo, and they recently shut it down. They failed. They couldn't do it. I think the TPU, Google has a very strong chip team, and TPU is a very credible part. I think Amazon bought Annapurna, and they've done excellent work there. Trainium parts and the Inference parts that they're using are designed not to be faster, but to be cheaper.
Like typical Amazon.
Yeah, that's right. And look, when you have as much business as they do,
Yeah.
that's a very
Cost of
reasonable
everything.
strategy. That's a reasonable strategy. I don't think it's a good strategy for a startup. To be 30 or 40% cheaper is not a good strategy. I think you want to be 10 or 15 or 20 times faster, and that's what we are. Microsoft has tried several times, and I think their strategies have not succeeded to date. Facebook has tried many times. They just acquired a RISC-V company. Their internal projects have not succeeded to date. So I think, all day, every day we see NVIDIA in the field. I mean, and we are, when speed matters, we're 15 or 20 times faster.
What do you think of what the different strategies all the big companies are approaching? Meta says it will spend, I don't know, I mean, I think some arbitrary number like 600 billion, right? I don't know how much of it they'll actually spend, but it's going to be a big amount. And
Big amount.
Google doing its own thing, AMD now sort of like becoming its own thing, Microsoft doing its own thing. How do you see the landscape there between different companies approaching this thing?
I think the landscape is being driven by both the hardware side and the software side, right? And the fact that we have such good open source models is driving a great deal. And the fact that some of these models were developed by Chinese companies has sort of given the U.S. A kick in the butt. And there's a lot of focus on that on the domestic front now. And so, look, the Qwen models are excellent models. GPT OSS 120B and 20B are phenomenal models. The first set of Llama models are still excellent. Llama 70B remains, for that size, an excellent model. But we now have real competition from China in the model making space, and that has enabled all sorts of small startups who are delivering apps to offer really cool things off an open source foundation. And that's driving a lot of the market right now.
Yeah, it's almost like we it's as big of a shift, if not more, as to the cloud, because pretty much behind at some point we didn't have cloud. At some point, cloud came up. Then every app we built is on the cloud, and every app that was on premises moved to the cloud.
That's right.
And now every new app will have an AI component, just like it will have a cloud component.
That's
And
right.
every old app will have an AI component as well.
Just like every app has a shopping cart,
Yeah.
right? And you bolt onto Stripe with 2 lines of code, right? You sign a contract and 2 lines of code and you got a shopping cart. In the same way, you can bolt onto us with 2 lines of code and you've got access to leading models.
Yeah. I mean, you mentioned Stripe. Stripe still remains a private company. They're huge, seemingly profitable. You did all the hard work to go public. You filed the S1, which is, I feel like, is the biggest hurdle to go to IPO, because, you're preparing all your information to become public. You put all the information out there and then you decided not to go public. Talk to a little bit about, what happened there.
No, we didn't decide not to go public. In fact, what we decided was we needed to revise the material, that the data in our S1 had gotten stale. And so we took it down and we told everybody that we would put it back up after we cleaned it up and put in more data and updated it. And it was stale, and it was from, I don't know, the summer of 24. And so it no longer was a good picture of our business. And the numbers were too small. Imagine how much stuff changes in 15 months in the AI business, and you've got a document that reflected your business 15 or 16 months ago, and you're doing more business, you have more customers, so we took it down and we'll put it back up, once we've cleaned it up and updated it and improved it.
Do you still plan to go public in the next couple of years?
We do.
Yeah. Because I mean, as a retail investor, I see, some amazing companies out there remain longer private. And I feel like retail is not getting the opportunity to participate in it.
Companies like DataStax have chosen to remain private much longer.
Yeah. I mean, Stripe looks like it will not go public anytime soon. They're even 40-year-old companies like Epic Systems, the healthcare software company, seemingly controls pretty much every aspect of healthcare in the US. Almost 70% of population indirectly uses them. They don't know it, but it remains to be public.
Epic's a beast.
Yeah. Why can't NVIDIA do something what you did in terms of I would say, scale up architecture of approaching it with wafer?
I think there are 2 answers. The first is anybody can try anything, right? I mean, I think that's number 1. I think number 2 is you also have to ask, why didn't they? Right? The question is often asymmetric. Why can't they do this? And the fair answer is, why can't they do it, and why didn't they? I think that's one line of thinking. And another line is, look, we have a huge number of patents, and many of the most obvious and most straightforward approaches are foreclosed because of our patent portfolio. But I'm very confident that companies work around patents all the time. I think the truth is it would take them 5 or 7 years and $2 or $3 billion, and we would still be 10 years ahead. That's the truth, is that for 5 years, we've been delivering. For 10 years, we've been building and inventing. We knew, for example, exactly why the B200 would be late. And it was late for an exact problem we'd solved in 2018. 7 years earlier, we'd solved the problem that caused them to be 18 months late.
And what was the problem?
Problem was the coefficient of thermal expansion mismatch between the chips and the interposer, and the interposer's bigger And the interposer, as it gets warm, will expand at a different rate than the chips, which are smaller. Expansion is a function of diameter. And so they'll be at the same temperature, but one will move more. And when you put one part on another part and you heat them both up and one moves more, you have a challenge. And we knew that and had solved that problem, 8 or 10 years earlier.
What's your take on, building, chips within the US? Are we bringing back, building chips in the US, or are we still dependent on TSMC building it offshore?
We're for aggressive geometries, right? For the most cutting edge, we're entirely dependent on TSMC. And it's not a good place, but they're an extraordinary company. And they are the best in the world right now at building fabs for advanced nodes, 3 nanometer, 2 nanometer, and below. And we don't have any of those fabs in the US for commercial business.
Do you see that changing in your time, or maybe in this decade?
You've got the right time frame. I think the building a fab, a fab is like a pyramid. It's one of the high points it's the greatest manufacturing plant in existence. And it might be one of the best things humans make, right? It's a $40 billion building, right? That is working at such small geometries that we measure them in atoms across, right? And you're making, you're using all of the scientific know-how that the world has produced to do that. It's extraordinary. They take 4 or 5 years to build. They have a 3 or 4 year life, profitable life. And we have none of them in the US right now.
What do you think about, you talked about DeepSeek and the challenge from China. What do you think about the geopolitics of whether or not selling chips? What is your general take on just selling chips to other competition? Or
we should sell chips to our allies and systems and AI to our allies. We should not sell them to our adversaries. Now, whether China should be in the adversary bucket or not is a question for others. For me, they've been designated adversaries. And as such, we shouldn't sell them chips.
In terms of, there's a lot of talk about AGI. And for me personally, that question doesn't really, matter that much, because I can see hundreds of applications where we can use LLMs, the current versions, without any meaningful step change.
That's right.
In everywhere. So do you have any thesis on AGI, or do you really pay credence to making the pro AGI argument and all those things?
I would say the following. I would say that there's a huge amount of productivity gain in business to be done that doesn't need anything close to AGI. For those of your listeners who've ever worked in a large company, the amount of time and effort that is spent cutting and pasting data from Salesforce to Workforce, right? This is not superhuman, and yet we've got legions of people doing it.
Yeah.
Auditing's not superhuman. Auditing is subhuman, subhuman intelligence, right? Machines could do a better job of that. I can list dozens of functions in an organization that would make us vastly more efficient. We don't need gold medal math capabilities. We need to be able to move a cell from one software tool to another software tool, right? Think of the things that are most aggravating in your day. Moving from a PowerPoint to a Google Docs to somebody who only works in Macs. None of the or many of the things that are so frustrating in day-to-day life are friction, that they aren't in need of superhuman intelligence. And so I think there is tremendous opportunity long before we get to AGI. I also think that my experience in technology is that the last 10% takes 50% of the time. And if you look at self-driving, it's a good example. We've been 90% of self-driving for a decade, right? And we're sort of there in a few cities, but not really generally. Not on freeways, not on trucks, not on, right?
It looks like it might take another half a decade.
That's right. I think what you'll see is, and that's been 15 years since the pioneers, Elon and others, were pointing it out, saying it's going to be tomorrow. And that's not because they were wrong. It's because they were wrong in timing, but the last 5% is really hard.
Yeah.
And always you think you're closer to the end than you are.
It's always easy to predict what happens. It's just hard to say when it happens.
Yeah, getting the timing right is really hard, for sure.
What are the underrated things that you think in AI right now? I think, everyone talks about some topics like AGI, OpenAI, but if you think about what are the underrated players or...
I think things that are underrated are doing simple things. Everyone's talking about doing hard things. I think doing the simple things that cause friction and cause frustration. I mean, payroll, matching payrolls to your subsidiaries, making sure, keeping track of headcount, even in the tools. I mean, HR tools are horrible. They're horrible. And AI can do a way better job. I think also all the way on the other end, I think a lot of time and effort has been focused on big models. And I think inference at the edge in tiny little sensors is a very, very interesting. I'm talking about the sensor by the brake of your car, right? I'm talking in that it can, or on the barrel of a gun for the military, or at the site of a manufacturing plant on the machine. I think there's a lot to be done there. And this isn't big AI. This is tiny little AI. This is AI that does a little bit of inference to be sure that the data sent back is the useful data, not the garbage. And I think in the sub-milliwatt and the milliwatt category of sensors with a little bit of AI on them, I think they're going to be, that's something people aren't talking about that I think is going to be very, very interesting.
And I think to enable that, you need to have AI that works on edge.
That's right. That's a super lightweight AI that's, it has a very different job. I mean, useful, not useful. I mean, it's trying to do a tiny little bit of analysis at the edge so that what's sent back has a higher proportion of signal to noise.
We featured a company called Web AI a couple of weeks back, and they're trying to do the same. They're trying to bring AI to the edge, and they're actually working in with some airline companies to do that on the airlines.
Right.
So that's a
airline engines are a perfect example.
Yeah.
You'd very much like to understand a huge amount of data coming off those.
So we're almost at the end of our conversation. I want to ask one question to you is, where should young founders look for ideas? And where should they probably go and work in the field of AI, or in general?
I think they should, in my experience, people are best at the things they really enjoy. And so I would begin in domains that you really enjoy. I have been at my worst when I end up managing or leading in areas where I'm not so interested. But if you're passionate and you write code to solve these problems in your free time, and you read, and I mean, then it's not work. Then you're just pursuing your passions. I would stay in that area for sure. and I would take seriously what your friends believe they need also, right? I think some of the best ideas came from young entrepreneurs and seeing holes in the tools that are available for them, the apps that are available to them. How come I can't tell if she's got a boyfriend? Well, there's Facebook. I mean, that's really, how come, I mean, and I've been married 30 years. That's not a question I ask. I could never have come up with that idea ever. Right. But at 19 or 20 in college, that's really important. And so, I think exploring around the things you know well is the best advice.
What is the most contrarian belief that you have these days?
I think we'll have peace in the Middle East sooner than people think.
Within this decade or within the
Yes.
next couple of decades?
No, within this decade.
And why do you think?
I think that the returns to being moderate have been demonstrated by the UAE. Right? In 2005, the GDP of Dubai was the same as Gaza. And in 2010, nobody heard of Dubai. Nobody was going on vacation there. And they chose a moderate path and have built an extraordinary nation. I think you're seeing that movement in Qatar. You're seeing that movement in KSA. I think in those regions, people are too busy to hate right now. They're busy working, busy building cool things. And I think that produces benefit for everybody.
Yeah, I think one of my favorite books is Matt Ridley's Rational Optimist, and he talks about
I like Matt Ridley.
Trade being basically how we all live together, because we
That's
trade
right.
with each other, and that's
The
how we
trade or building things together.
Yeah.
I mean, I got an email from a guy a manager reminding me to wish one of my team members happy Eid. So this was a Hindu sending an email to a Jewish guy reminding him to wish a Muslim happy Eid. Now that happens in Silicon Valley because we're all working together to build shit. We don't care, right? The only question is, can he or can she build something cool? Are they a good team member? And I think if we trade, we do business together, and we build things together, then there's nothing to hate.
Yeah, I think that's a good note to end the conversation. Andrew, thanks again for being on the show.
Thank you for having me. I really appreciate it. It was a good conversation, Nataraj. Be well.